Okay, then I think so. I'll start with the session. I guess, yeah. So, first of all, the topic is about how to get started in Web3, and it is related to blockchain. And the contents, and I can say, like, if you have anything in whatever that comes into your mind when you hear blockchain on Web3, you can type it in the chat, any terms that you might have heard, something like that. Okay, crypto NFT. Yeah. So like when I started, that was also like these were the terms that I used to hear, and they used to look a lot of intimidating to me. So with that terms, let's start with the session, and I'll be covering those terms too in the session itself. So firstly, I'll be talking about Web3 and blockchain and how they are connected. They are both separate terms. Don't take it as like Web3 and blockchain are the same. Second will be part to Web3, like how do you actually start learning it, and the third will be where to find actual resources, because you might be feeling that you might not like which where to start and which resources to refer. So, if we talk about Web3 and blockchain, and let's say, really when internet started, we just had a static HTML where you can read from stuff. You just read, but you are not giving any input. So that was Web 1, if you can see. But when Web 2 came into existence, it was basically created during Facebook. When Facebook was invented, we could actually post something. So that was the right part. So the read and write part came into the Web 2, where you can actually read the content, interact with it. Like if you're on Instagram, you can see the post and you can like it. So this is you writing giving something to the website. So like everything is going to fine till now with Web 2. So why was there a need to coin a term Web 3, or why was there a need to use Web 3? There are certain reasons for that, and one of the reasons I could say is banks. So if I talk about banks, if you're making a transaction, so what happens is whenever you pay some amount of money, like transfer some amount of money, a little amount of transaction fees is taken by the bank itself. So the bank is a middleman. So that is like if you're making any international transaction, so it converts your money in the currency and all that. So it takes a lot of transaction fees, and it also gives banks a central authority being the middle person, right? So this is why there was someone named Satoshi Nakamoto. That person is an unknown person or a crypto person who we don't know that actually. It was just an anonymous person who invented or coined the term Bitcoin. I guess you might have heard about Bitcoin, and this was invented at around 2008. So what Bitcoin did, it was like a global coin, right? So it gave us the power of not taking those transaction fees. So this is how decentralized finance came into existence. I'll just let it. In. Okay. So when we talk about banks, these banks have a central authority, right? Also, when we talk about the website, okay, I'll just let people in. Okay. So hi Irfan, hi Vedant. Yes. So when we talk about Web3, like Web 2 has a central authority. Like you might have heard the code that if you're not paying for something, then you are the product itself. That's why we get so many customized ads on websites. Like you're reading something, and on the side you have these ads and all that. So that's what Web 2 has right now. Even like you might have come across these memes and all, where they say like if you're talking to someone on WhatsApp regarding something that you wanna buy, the next day you get the same ad about it on Instagram. So this is how like our data gets leaked and used for advertisement because of the central authority that we have in Web 2. That's why because of these reasons Web 3 needed to come into picture. And the reason how why web we need Web 3 is because it uses the power of blockchain and decentralizes it. What I mean by blockchain or decentralization is blockchain is a technology which has these, if you can read here, it is decentralized, distributed, peer to peer, transparent, immutable, and secure. By decentralization, I mean the network is not just one server client model, it's a peer to peer network. I guess guys might have heard about uTorrent, that like earlier we used to download stuff or movies from uTorrent. And one of the reasons that we used to use that is because it had a really good downloading speed, right? And the reason it was that because it was using a peer-to-peer network. What happens is there are set of computers or a network of computers, and when you download something, it checks if any node which is near you has that movie, and it downloads. So it gives you a better download speed. So blockchain uses a peer-to-peer system. It is decentralized. By distributed, I mean if there are a set of networks on the blockchain, all of those computers or nodes will have the same data, same ledger of the blockchain. So the whole data is distributed. There is no server or a central system here. Transparent, by transparent I mean the whole data is public. Like if you are working on any blockchain, let's say Solana, so you can go to the Solana Explorer and enter the signature ID or the transaction ID and get the a transaction made. So it is transparent. The second last thing is blockchain is immutable. By immutable, it cannot be changed, and I'll be explaining it with an example in the next slide properly what immutability is. Basically, you cannot change the data, and like what happens if somebody changes the data. I'll also give an example of that. The last thing is blockchain is actually really secure. So if we actually look into how blockchain is and what is exactly blockchain is like a set of blocks, as the name itself suggests. And how are these blocks chained together is like a really interesting thing. If you look here, I'll just go to the demo. Can you guys see the demo screen? I'll have to reshare my tab. Actually, yes. Okay. So can you see the demo screen? And here you can see, I'll just go to blocks. Blockchain, yes. If you see, if this website gives you like a small example of how a blockchain might look like. This is a single block, and there are a lot of stuff that comes into a block which are not written here, but this is enough to explain you the little bit concepts about blockchain. If you look here, all these blockchains are connected together, and how they're connected, if you see the value here, it is the same as the previous hash, and for the hash value here is the same as this previous hash. So this is how the whole blockchain and the chain system is created in the block. And the first block is called as the genesis block because it doesn't have a it doesn't have a previous hash. Okay, so if let's talk about hash functions. I guess you guys might have heard what a hash function is. To give you an example, let's say if you have a data and you pass it into a function, it gives you another data. It basically takes something and it gives you some output. It the What it does, it takes the input, manipulates it in somehow, and gives you an output. Let's say if you have a value 5, then it will add 5 to the data and give you as output. But the hash functions are really complex in blockchain. So let's say if I write hello Anam here, so you can see as in when I'm typing, the hash function changes. So what happens, every data has a unique hash function. So this is how if you see here, a block is like this. Now let's say if I write hello and I mine it. I'll talk about mining term in 5 minutes. So you can see the hash function generated here is this. But if I tamper with the data, let's say if I do hello, you can see the block turns red because the hash function changes. And if this hash function changes here, it won't match with the previous hash, right? So I'll just mine this one. If So this hash function changes when we change the data. Now this doesn't match with this. So what happens? The whole blockchain gets corrupted if you change the data. So that is what I mean by immutability in blockchain. Coming back, I guess I talked about blocks, hash, nonce, and mining. Now, if I go over to the example again, so what happens in the hash function is, if you see here, the first four digits are zero. Even if you've seen other blocks, the first four digits are always zero. Now, this is related to hash collision, which I don't want to get in. But what basically happens is, if I put some data in the blockchain, I want something which should come out like this. If it doesn't, then I put the data again and again and again and again, like the whatever output I'm getting, I'll put it again as the input, and I'll do it a number of times until I get the value, the first four digits as 4. So the number of times I put the value in the hash function again is called as the nonce. So you can see like this is a really big number. Like the data got put into the hash function for 11,000 times. So this is basically what a nonce does. Now, where does mining come into picture? What happens in mining is, like, you might have seen that I was clicking on mining when I was changing the data. So when I change the data and I click on mine, it generates the value of nonce and hash function again, right? So what are miners? When we add a data to a blockchain, we need to calculate the hash function and the nonce for that block, right? So miners are like a set of computers or anyone who actually calculates this hash function, and whoever gets it first, whoever gets the correct hash value first, can add the data to the block. So this is where mining comes into picture. If you look here, as I said, blockchain is a set of nodes or set of computers. Like if you see A, B, C are here the nodes of the blockchain. And what happens if C wants to add some data into the blockchain, it needs to get a majority vote or something. It is also called as consensus algorithms, and every blockchain has their own proof of work or proof of history for that. So that is what happens, and every block needs to be mined as in their hash function, hash value and nonce has to be created. And there are certain miners, or you might have heard about the term mining farms and all that, who calculate this hash function. But you see, as you can see, there are a lot of like, it takes a lot of time to actually calculate the value if you're calling the function again for 20,000 times or 10,000 times. So it takes a lot of computational power, right? So the miners get compensated accordingly, and they get rewarded. So there's a rewarding system. They get rewarded in whatever coins is, like if they are Bitcoin miners, so they get rewarded in Bitcoins. So this is what nonce and mining is. Nodes, there are different kinds of nodes: partial node or full node. A full node is basically which has the whole copy of the data, of the whole blockchain data. So if A is a full node, then it will have the whole blockchain copy. If I go here, you can see this is node A, which has the blockchain, and this is node B, node C. But if I change the data here and I mine it, this will not match with the data in block A and block node A, right? So this is how immutability is also achieved, because everyone has their copy, and if you tamper with the data, it is evident that this node is faulty or it's been compromised. Moving on to public and private keys. Every wallet ID, or there are two types of keys: public and private keys. Public key is obviously visible to everyone, but you always have to make sure that your private key is not being displayed or anybody knows your private keys, because this is how you sign your transactions, and this actually shows that you own the content on the blockchain. Sorry, I'll just let people in. Yeah, so that actually means you own the content on the blockchain itself. So what happens, whatever you sign with your private key can be viewed using your public key. It's something like if you go more into cryptography, then you might understand what happens with public and private key. Right now, I'm just going through the basics. So the last thing that I want to discuss in this in the terms is smart contracts. If I talk about a normal contract, let's say I have a deal with someone, and I agree to my end, and the other person just bails out or doesn't live up to the end of his deal, right? So that is like, even if I give like my share of side, the person doesn't give. So that actually is based on trust, right? Contracts. But when we talk about smart contracts, these are based on code, right? So what happens with code is, after both have given their share of the are living up to their terms, then the smart contract is automated. It's basically an automated transaction and it is written in code. And you might be hearing a lot of these words like smart contracts when you start with Web3, because we will be when you make a D app, or when you create a web app based on Web3, you will be writing smart contract for it, and it will be an automated transaction. Moving on, if we look at a D app, which is a decentralized application, it is a normal web app, but it is made using Web3 and blockchain. If you look at the off-chain part, the front end and the back end is same, right? And the front end is always connected with a wallet. If I talk about normal Web2 that we have right now, we have a login where we can log in using Google or LinkedIn. But here in block web app, we always ask you to sign in using your wallet. You can actually install some extensions like Phantom or MetaMask to log in using your wallet. But if we go on chain, the on chain is where you write your smart contracts or your blockchain related to part. And this is where the blockchain part comes under. If you already know like how to make a web app, or you already know Web2, then it will be really easy for you to learn blockchain, because this off-chain part is you already know the off-chain part. You just have to learn the on-chain part. Now there are different types of blockchain that are available. Like Bitcoin was the first one. I guess I might have forgotten to write it here and instead wrote blockchain. So there are basically two types of blockchain. One is Ethereum based and another is non-Ethereum based. So the if you see Avalanche, Pulse Chain, Polygon, Binance, and Ethereum are based on Ethereum virtual machine, and Solana and Terra are not non-EVMs, EVM ones. So what basically happens is if you learn Ethereum, you can easily adapt to Polygon or Binance or Pulse Chain. And Solana and Terra have a really different architecture. Currently, I'm working in Solana itself. So yeah, these are the different kinds of blockchains available here. Moving on, so the whole agenda of the meet was to get you all comfortable with the concepts in Web3 and blockchain. And the second part consists of part to Web3, like how do you start learning it, what all resources you should access, and all that. So when I talk about part to Web3, first thing will be learn blockchain concept. Like you can take out 3 to 4 hours of your day and spam yourself with contents. Go on YouTube, go read some blogs if you are comfortable with blogs rather than YouTube videos. Read Twitter threads and start understanding these concepts. Whatever I taught just now were just basic concepts, and I just I guess touched the tip of the iceberg. But as and when you start exploring the environment, you get to learn so many concepts. And that is really important when you start with Web3, is learn blockchain concepts. Second is write smart contracts. Now, about smart contracts, first you'll have to select the blockchain that you'll start with. And I guess I have heard from other Web3 developers that Ethereum is the a really good choice to start if you're a beginner, because the smart contract written in Ethereum is written in Solidity language, which is kind of similar like JavaScript, so it will be easy for you to adapt. Then also there are also other blockchains called as Solana, Polygon. So after learning these blockchain concepts, you can move on to writing the smart contracts itself. After your backend or of on-chain part is complete, you can learn front end, and I think most of you here might have some experience with front end, so that's a really good point. You can write the front end in React JS, Vue.js. Also, if you're working
Hey
with a
Anam, are you sharing the correct screen?
Oh, I'm so sorry. I was not on the screen. Okay, I'm so sorry. Wait, I'll just share the PPT. I was actually explaining from the PPT itself.
Yeah.
Okay, so I guess I might have not shown this slide. So this is what the on off chain and on chain diagram looks, and I was explaining from this diagram itself. So as you can see, there is a front end, the back end, and you have to connect it with your wallet. And if you see, there are smart contracts written on the on chain part, and the different types of blockchains I mentioned. I hope I made sense without the PPT. If you have, I'll explain it again in the end if you might have missed. So, as I was saying about part 2 Web3, first thing that I talked about was learn blockchain concepts. Second was write smart contracts. You can select Ethereum, which has Solidity for its smart contract language, and it is similar to JavaScript. Third will be front end. You can go with React.js, Vue.js, and if you're looking for mobile applications, you can go with Flutter. I guess Android Studio doesn't have that much libraries to connect it to blockchain, but Flutter has. So you can also go with that. Last thing will be connect front end to back end and deploy. You can basically, like, I also get these questions that how can you deploy your code on like how do you deploy your code? So whatever your off on chain code is smart contract gets deployed on the blockchain itself, and your off chain code gets deployed on whatever hosting site you choose, maybe Netlify or Vercel or any site that you prefer. So if you, and you also need a little bit of GitHub, because if you are making some project, then it is really good to showcase it on GitHub itself and like learn a little bit of Git versioning system. So basically, even if you are a beginner and you haven't any explored any development yet, you can still start with Web3. First thing is you gotta start with blockchain. Second, write some smart contracts. Third will be learn front end. If you already know that, then that's really good. And the last will be normal deploying part and GitHub part. So the last point is learn from resources. So there are a lot of resources available here, but I've bifurcated them in like 5 parts on how to use which platform to get the perfect resources. As I said, the first part will be to spamming yourself with content. So you can start with small YouTube tutorials of 10 minutes and read blogs if you like. So start reading about these concepts. Maybe you can watch some YouTube video, 3 4 hours YouTube video where they're making the project and make it side by side. After that, you should go with the official documentation. The reason why I'm saying that don't start with the documentation first, because there will be so many terms coming in and it might get a little bit boring. So after you have like done a little bit research on YouTube and blogs itself, you can move on to the official documentation, because it gives an in-depth knowledge of the blockchain itself. And as far as I have seen, like blockchains have really good, all the blockchains out there have a really good documentation system, so you can it's really user friendly. And the third will be Twitter. For Twitter, I think so Twitter is mostly good for reading threads and like anything that is happening in the blockchain world, any news. So what happens when, because there are so many concepts that you might not study it in one go, you might hear it from any tweet or any Twitter thread that you might have missed. So this is where Twitter comes into a help. You can read about any news or anything that is happening, and you can be up to date with the whole environment itself. The fourth will be Discord communities. Discord communities can help you in solving your doubts, because what happens is, if I give you an example of my like I was following this tutorial like a long back, and the tutorial was 1 year old when I was you actually referring it. So what happened? Some of the code, like something changes in the code base, right? Some method gets deprecated or something like that, so you might not know about that. So if you go to this Discord communities, you might ask people to help, and the tech community is always really helpful and open, and you can shoot your doubts, and every blockchain has their own official Discord. You can go and join the Discord servers and ask your doubts there, and it will be really helpful, and people are actually really helpful in the Discord communities. Last thing will be learn from projects. And it is like a really important point. If you're following a tutorial, don't just blankly stare at it for 10 minutes, and because you'll obviously forget it. So always make notes or do the code side by side, so you get these experience, and it will give you first of all hands-on experience. Second thing, any issues or any error you face there, you can get it resolved in the Discord communities or ask in the comments itself. Third thing is you also get a good thing to showcase your project itself, right? Whatever you're making. And my advice will be always go with something like after you make after you learn a feature or any concept, make something out of it by customizing that feature. Don't copy it same as the same code base from the YouTube tutorial. Try to add something of your own, so that will be a good thing. So I guess that is it for this slide, that you can refer these five things. I've also made a summary of all the resources that I refer and I've seen on Twitter or YouTube, and I've created a summary of it. I'll just share it on in the chat. So that is it for the session. It was, I kept it short because blockchain can be really intimidating if you're hearing for the first time. And if you have any questions, you can ask here, and also you can reach out to me at my socials. Yes, I'll just paste the summary for the uh, summary resources, whatever I had here. Also, I guess Rahil mentioned about NFT. So NFT are something like that. If you might have seen those art exhibitions, right? When there's a art displayed and people like bet like just give so much amount of money for getting that certain piece of art, right? So what happens in NFT is also an art piece, but what happens using blockchain, you can be the sole owner of the NFT. You can obviously take screenshot of the same art and keep it, but you can't prove that you're the owner of that NFT art. So what happens using the power of blockchain, you can actually prove it that you're the owner. That's why there's so much craze regarding NFT. Yes, I guess Pooja and Steve joined a little bit late, so I might have you might have missed a uh little bit of concepts. So if you have any doubts, you can ask, and we'll be also posting the recordings of the lecture on YouTube. I guess I see no doubts here. So Isha, are you there? I guess he's is not here. So if you have any doubts, you can ask me in 2-3 minutes, or we'll just end the session. And if you have not copied the summary, I'll also paste it in the Discord channel, and we'll be posting the YouTube recording itself.
Hello, Anna. I
Yes.
actually have one question. So there is this tutorial on like free code camp channel, which is like very long. So like, would you suggest it to like follow it, or like is it better to like just like to do the things in a way that you have mentioned?
Okay, about long tutorials is like if you're really motivated that you'll follow through, then that's a good point. But if you're like me, because I don't think so, I can go for long tutorials. I always like to mix up and like go to YouTube and start with that. But what you can do, like if it's a free course, you can start with it a little bit. So
Okay.
it's to give you an introduction, and because it's a free course, you can leave it anytime and you can start on your own and start finding resources, but it will be a good start for giving you a little bit introduction to the concepts and all that.
Thank you.
You can share the resources in the chat itself if somebody
Uh,
wants that.
okay, okay. I'll just paste the link.
Okay, then if anybody doesn't have more doubts, we can end the session. Before ending the session, I always take screenshots. So if you're comfortable, you can turn on your cameras and I'll be taking a quick screenshot. I guess that is it. So thank you all for joining, and I guess that was the last session for our summer boot camp. So yeah, we'll be coming with more sessions and more news in next week maybe. We are working on something new, and yeah. So okay then, bye.
Just a 1 minute thing.
Sure.
Soon we are gonna roll out a feedback form, and we would really appreciate you mention all the good stuff. All we would prefer more of the uh, bad stuff or anything which you felt could be improved. So we will roll out today itself, and it will be really awesome if you folks and the earlier people who joined. I'm saying here right now because you are the only one present here. But yes, we would really love it if you could share the feedback on our event itself. And yeah, that's it then.
Okay then, bye.
Yeah, Anam, you should just stay here. Others can.
Okay.